going to use the definition of a derivative. Let's start by writing that definition out. F prime of x, which stands for the derivative of the function, equals the limit as h approaches 0 applied to the difference quotient. Okay, so from this point on, what we want to do to get started is we want to basically set up our difference quotient. If I'm trying to figure out f of x plus h, I know I'm supposed to take x plus h, go back to the function as it's defined, and replace those x's with x plus h, right? So if I set up my next step here, this limit tag, it just stays there. It stays there until I have this simplified function to apply it to. So in simplifying the function, now I'm using the difference quotient. As I already stated here, I'm going to take this x plus h, I'm going to plug back in for the x's up here. I'm going to have 2 times x plus h as a quantity squared minus 12 times x plus h plus 3. Everything in blue there is f of x plus h. As we continue with the difference quotient, we're subtracting f of x. Well, f of x is the original function. So I'm subtracting, as a quantity, 2x squared minus 12x plus 3. That is all over h. All right, now we got some work to do. We got some binomial expansion right here. We got some distributing. And we got some terms to put together. So I need to give myself a little more room here. I'm still in the simplifying process, so I still have the limit notation. Okay, if you need to, let's do this. Take this x plus h as a quantity squared. Let's figure that out off to the side. X plus h is a quantity squared. Might remember the shortcut. If you don't, all you're doing is you're taking x plus h times x plus h, right? You FOIL that out. Got x times x squared. Outside terms, you've got x times h. Inside terms, you've got x times h. So we got 2 of those. And then the last terms, if you multiply h times h, get h squared. So there's x plus h as a quantity squared. Figured that out off to the side. The reason I did that, to save myself a little writing, I know I got to take this 2 right here and distribute. So this 2 gets distributed to the x squared plus 2xh plus h squared, and I get 2x squared plus 4xh plus 2h squared. All right, so I've taken care of this part. Now let's just distribute with the rest of this. With the rest of this, I'll distribute the negative 12 to begin. Get negative 12 times x. Got negative 12 times h. Got your plus 3. Got a negative sign here to carry through, so that becomes minus 2x squared plus 12x minus 3. A lot of signs changing, right? In the meantime, that is all over h. We've done enough difference quotient problems in the past that we're supposed to understand where this is going, right? If we're doing this correctly, some stuff should start canceling out, and we should get to the point where we can cancel out this h somehow. So if you collect your like terms in the numerator, notice what happens. You've got some x squared terms that cancel. You've got some x terms that cancel. You got some constant values that cancel. And what's left? Got an x term here, got an x term here, got an x term here. Say an x term? H term, sorry. Those are h's. Yeah, we want h terms that are left. I misspoke. So with those h terms that are left, we now can divide this h into all of those h terms. When we divide that h into all the h terms, still applying the limit because we're not completely done with the simplifying process. Let's see. H goes into 4xh. I'm left with 4x. H goes into 2h squared. I'm left with a positive 2h. And h goes into the minus 12h. I'm left with minus 12. There's the simplified form. We're finally ready to apply this limit. And if we're applying that limit as h approaches 0, that means any h that I see over here, I'm going to plug 0 in for. So I've got one term that's got the h in it. I plug in 0 for that term. Well, let's see what's left here. F prime of x is going to equal, this h term's gone, so 4x minus 12 would be left. The derivative of the function is 4x minus 12. All right, if we're going to find f prime of 1 here, well, we have to know what f prime of x is. We found f prime of x to be 4x minus 12. So all we're going to do here is we're going to replace x with 1. F prime of 1 is going to equal 4 times 1 minus 12. F prime of 1 is going to equal negative 8. Now, to appreciate what that negative 8 means to us, that's why I've got this third question up here. Using the work again from number 1, and now, really, when you read the question, number 2, we can find the equation of a tangent line to the curve y equals 2x squared minus 12x plus 3 at a given point of 1, negative 7. Notice this function here. Go back to number 1. Same function, right? So if we're going to find the equation of a tangent line, we know if we use point-slope form, we can plug in a point, we can plug in a slope, right? So we're given a point. If I start to plug in what I know, I've got y minus the y sub 1 value, so the y sub 1 value is negative 7, it'd be y plus 7, equals the slope, which has kind of been the thorn in the side, right? That's been the hard part to figure out, times x minus the x value at the point. We know this sets up the answer that is our equation, but how do we figure out the slope? Well, with what we now appreciate about a derivative is a derivative gives us a formula to find the slope. If I know f prime of x equals this 4x minus 12 up here, then I know my slope is going to equal that same expression. 4x minus 12 is my formula to figure out the slope. So x is 1, right, at this point. You take 1, you plug in. Of course, we already did this in number 2, right? We're going to get the same answer back, which is negative 8. Meaning our slope for this equation of a line is negative 8. The derivative gives us the slope formula. All right, so going back, using the work from the first example again, we're going to find the velocity of an object in motion represented by this equation at 2 seconds. Keyword here is velocity. When I see velocity and I see a given equation, like I do right here, I'm going to take the derivative of that equation. Now that's the same equation we had back in number 1. We've already taken that derivative, so if we carry the derivative over, f prime of x equaled 4x minus 12. That was the result we found from number 1. That derivative right there represents the formula we need to figure out the velocity. So we're talking about a time of 2 seconds. What are we going to do with that 2? Just plug it in for x, right? We want to find the velocity. Velocity is going to equal 4 times 2 minus 12. Got 8 minus 12, negative 4. Got no units of measurement to work with on this problem the way it's given. We could say meters per second, something like that, but negative 4 is the value that we get back.